Today we're going to be talking about section 5.4, which is on indirect proofs. Indirect proofs use what are called indirect reasoning. It's where you assume that a conclusion is false and then show that this proves that the assumption led to it is a contradiction from what they've given you. So in an indirect proof, or it's called a proof by contradiction, you assume that what you're trying to prove is false. And then showing this assumption leads to something that's impossible, you prove by using a negation. So this is how it is set up. Step 1, okay? You identify the conclusion that you're asked to prove, make the assumption that this conclusion is false by assuming that the opposite is true. So whatever they say is your assumption or the conclusion, you take it as false. So you do the opposite. Then, using your logical reasoning that you've done different ways through proof writing and whatever else, it leads to something that isn't true. Okay? Leads to the contradiction of this hypothesis. And then finally, since you say, okay, well, since the assumption led to a contradiction of what they've given us, then the original conclusion, what you're asked to prove, must be true. So it says, if something that isn't true goes to an answer that isn't true, then something that is true must go to an answer that is true. Kind of flips it around on its head. All right, so look right here. It says, state the assumption necessary to start an indirect proof for each statement. So what we want to do is look back at when you have a statement to find the hypothesis and the conclusion. So the if was always the hypothesis. If 6 is a factor of n, led to our conclusion, then 2 is a factor of n. So if we're going to write our assumption for an indirect proof, we take the conclusion and do the negation of it. So instead of saying 2 is a factor, you'd say 2 is not a factor of n. That would be the assumption necessary to prove indirectly. Next, angle 3 is an obtuse angle. So if that's our conclusion, then the negation of it would be that angle 3 is not an obtuse angle. And you could say that there's right angles or acute angles that also make it true. Here's our guided notes problems. If x is greater than 5, what would you want? The negation of that to start proving by contradiction. And in letter B, XYZ is an equilateral triangle. So what's the negation of equilateral triangle? So we're actually going to start trying to write some indirect proofs here. Okay? So it says write indirect proof to show that if negative 3x plus 4, that quantity is greater than 16, then x has to be less than negative 4. So, hypothesis, conclusion. Okay? Conclusion is this. X is less than negative 4. So what's the negation of x is less than negative 4? Well, we're going to assume that x is greater than or equal to negative 4. So let's look at that right there. Okay, so let's say x is greater than negative 4 or x is equal to negative 4. That's essentially what greater than or equal to is. Greater than negative 4, equal to negative 4. So now I'm going to take that and I'm going to take some values that are greater than negative 4. So a value greater than negative 4 would be 0. Okay, so let's say x equals 0. And then the other one they give us we have is just x equals negative 4. Now let's take those values and plug them into our given statement. Okay, well, negative 3 times 0 plus 4 is possibly greater than 16. Well, negative 3 times 0 is 0. 0 plus 4 is 4. 4 greater than 16. Is that true? No, that's not true. Try the next one. Let's put negative 4 in. Negative 3 times negative 4 plus 4 is greater than 16. Well, negative 3 times negative 4 is 12 plus 4 is greater than 16. This says 16 is greater than 16. Is 16 ever greater than 16? No, that's not true either. So, by contradiction, it must be true that x is less than 4. So, you'd write by contradiction, x is less than negative 4. And if you want to box it so you know it's done, you sure can. Here's some examples of indirect proofs that you can try, A or B. If you want to try A, 7x is greater than 56, then it must be true that x is greater than 8. That's very similar to the one we just did. One that might be a little bit different you could try is letter B. If negative c is positive, then c is negative. Here's an indirect algebraic proof. Javier asked his friend Christopher the cost of his meal and his date's meal when he went to dinner for prom. Christopher could not remember the individual costs, but he did remember that the total bill, not including tip, was over $60. So Christopher, his prom date was over $60. Use indirect reasoning to show that at least one of the meals costs more than $30. So, given this, we need to prove this. Prove that x was greater than 30 or y is greater than 30. So at least one of the meals was greater than 30. So the conclusion is this part right here. X is greater than 30 or y is greater than 30. So let's assume the contradiction. So the opposite of x being greater than 30 would be x is less than or equal to 30. And y less than or equal to 30. Okay? So if you know that x is less than or equal to 30, and you know that y is less than or equal to 30, let's plug them both in. Let's say x plus y has to be less than or equal to 30 plus 30 because x was 30, y was 30. So this would say that x plus y is less than or equal to $60. But our original statement said that x plus y had to be greater than 60. So this right here, less than or equal to 60, can never be greater than 60. So this is a contradiction. So you'd say by contradiction, x is greater than 30 or y is greater than 30. Box it and we're done. So here's a guided practice problem. You can try that one now. Example 4. Example 4 says this. Write an indirect proof to show that if x plus 2 is an even integer, then x is an even integer. So, given x plus 2 is even, prove x is even. So what I'm going to do then, look at this conclusion right here, and we're going to assume the opposite. Assume x is odd. So a way to write an odd number is 2x plus 1. Okay? Actually, I'll use a different letter instead of x so we don't get confused. How about we say 2k plus 1. Okay? So x is equal to 2k. So it's an odd number. So let's take this odd number, 2k plus 1, and plug it in right here for x. And so we'd say 2k plus 1 plus 2 should be odd. Okay? So what I'm going to do then is say, well, 2k plus 1 plus 2 would be 2k plus 2 plus 1. Right? Commutative property says that those two could switch around. Well, if you take this out right here, if you're looking at this, you'd say, I can take it 2 out of that, be k plus 1 plus 1. So if you let k plus 1 right there be a different integer m, 2 times m plus 1, it looks very similar to this right here, which we said is odd. So by contradiction, if x is odd, I get an odd number out. So if x is even, x plus 2 is going to have to be an even number as well. So by contradiction, x is even. You can box that so you know you're done. So let's use indirect proofs to prove something in geometry. So back from section 5.4, we talked about the exterior angle theorem. Okay, it said that angle 4 here should be greater than the measure of angle 1 and the measure of angle 2. So, given angle 4 is an exterior angle, prove the measure of angle 4 is greater than the measure of angle 1 and the measure of angle 4 is greater than the measure of angle 2. So we need to take first the assumption of the negation of what we're trying to prove. So let's assume the measure of angle 4, well, the opposite of greater than would be less than or equal to the measure of angle 1. And the measure of angle 4 is less than or equal to the measure of angle 2. Okay? Well, back from the exterior angle theorem we did previously, we said that angle 4 here has to be the sum of these two angles. So we're going to say the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. But if you look at this part right here, the measure of angle 4 is less than or equal to the measure of angle 1, we can actually say the measure of angle 4 equal to the measure of angle 1. And we're going to take this and we're just going to substitute and say, well, then the measure of angle 4 is equal to the measure of angle 4 plus the measure of angle 2. Because we just said, okay, well, 4 is the same as 1, then we can take this one and put in angle 4. Well, if you have the same thing on both sides of our equal sign, they cancel each other out, right? By subtraction, they cancel each other out. And so you'd say 0 is equal to the measure of angle 4. Well, can you ever have a triangle with an angle of 0? The answer is no. So, by contradiction, the measure of angle 4 is greater than the measure of angle 1, and the measure of angle 4 is greater than the measure of angle 1. Box it, we are